here's another function. Again, same directions. I just want to find all of the critical points. So we start by finding the gradient. That's f sub x, f sub y. So let's see, that's going to be 2xy minus y squared minus 0, because that's constant with respect to x. Whoops. Comma, that was just the first component. Second component is the partial with respect to y. So that's going to be x squared minus 2xy minus 1. Now, both of those are just polynomials in x and y, so they're always defined. So again, we see we've got no critical points because the gradient is undefined. So any critical points are going to come to us by the gradient of f being 0. And that's going to mean that 2xy minus y squared equals 0 and x squared minus 2xy minus 1 equals 0. Now, both of these equations involve both variables. This one I can factor a little bit. I can factor out y to get times 2x minus y equals 0. This one I can't even factor. Okay. So here, it's not a question of solving two equations one at a time. I want to remember it's about solving this system of equations. So, because I was able to factor this one, I know I've got two possibilities, either y equals 0 or 2x minus y equals 0, which would mean y is equal to 2x. Now, neither of those gives me a full-on point, but I can now combine them with this information. Okay. So, over here, if y is equal to 0, which is the first way I have of satisfying this first condition, my equation becomes x squared minus 1 equals 0. Okay, so x would equal plus or minus 1. So now I've got two critical points, 1, 0, and negative 1, 0. Do be careful. I found the y value first, but make sure you list it as the y value, not the x value. Okay. Now my other possibility was that y could equal 2x. Well, if y equals 2x, this becomes x squared minus 2x times 2x minus 1 is equal to 0. So that's x squared minus 4x squared minus 1 equals 0. That would be negative 3x squared. I'm just going to add over that 1 equals 1. That's actually not going to have any solutions because this side is not positive, but obviously 1 is positive. But notice in working with the system of equations, I had to take conditions from one equation and plug them into the other equation. Something we do all the time in solving systems of equations, but the last examples were sort of so nice that we could work with this equation over here all by itself. Here we had to actually let the two equations interact. So those would be my two critical points for this particular function.